What's up, everyone? How's everyone doing? Woo! I'm super excited to kick off this session with y'all. I'm RJ. This is From Four Wheels to Two, launching Lyft scooters, engineering principles for fast-paced, wheel-spinning product development. And this is my first time in Russia. I'm super excited to be here in Moscow for the very first time with y'all. I'm from Chicago originally, and so this weather is pretty much what I'm used to. It's great. But I wanted to kick this off. I've been really debating the right way to start a talk like this because I'm going to be talking about product engineering principles, and I'm going to be talking about a lot of kind of abstract stuff about mobile development. So I decided to tell you one thing I want you to know about me, and that is I'm RJ from Chicago, and I'm a hacker. I don't know if any of you have played with Kinects as a kid. They were kind of like Legos back in the 90s. Anyone use them? Maybe, okay, a few of you. All right. They were the coolest. You could build anything you wanted to with them. There was no set design on the box. You just got to do whatever you wanted. And as I grew up and I got older, I applied that lesson to everything I did. I really got excited back when I was in university and I built a giant touchscreen table. And my motto was just build cool stuff as fast as you can. And that really worked well for me. Come on, buddy. Come on, buddy. Hold on a second. There we go. So in 2010, I discovered Android development for the first time. And this is the absolute coolest because it was the ultimate hacker platform. You could do anything you wanted to on it. It was an infinite playground to build anything. And so I made a career out of this. And I just went really deep into building it. This is me winning a hackathon. I'm so proud of this in 2011. I spent 2 years at Hulu, which is a kind of a media company in America. I spent 4 years at Google building out apps. But I built a lot of stuff that didn't ship. I built a lot of stuff where I worked really, really, really hard and nothing came of it. So I kind of got burnt out. And I thought about it and I came up with a new motto for my life. And that is waste less precious time and make more meaningful stuff. And I've gotten a lot of other hobbies. I really love snowboarding. And every time I spent on my computer, I wasn't out on the slopes. So what I really loved at the end of the day was what I was building for people. And building is fun, but really the satisfying moment is when I deliver something to my user and I try and help them. And so I think that's when I transitioned from being just a software engineer to being a product engineer. Because I think when you focus on the software you're building, you're a software engineer. When you focus on the outcome of what you do, you're a product engineer. And the way I saw it is product engineering, it applies to all mobile engineers, but when your outcome is to ship a meaningful product, I found that focusing on 3 things really, really helps you succeed. And the first one would be maximize your effort that you're spending, owning what you code, and then shipping meaningful stuff. And I'm going to go through these principles, and there will be some code and there'll be some examples. But I found that this was one of the ultimate ways I could find satisfaction in what I did and not get burnt out. So I'm going to tell this to you through a story that happened to me in 2018. It's a true story. It was kind of a whirlwind of a time. And when I got to step back and think about what I did, I found that these principles pretty naturally emerged. So I'm going to tell you about 3 specific engineering principles I used to guide me through this really intense effort. And I'm an Android engineer, so there'll be a lot of Android examples in here. But I really hope that all mobile engineers can take away that these principles help you through any mobile product you're doing, where your ultimate outcome is to build something you're proud of and help someone. So the story starts like this. One day, a coworker just said, "Hey, we want to build a scooter sharing service. Do you want to join?" Sometimes some of your biggest works in life come from a huge amount of buildup you've been planning for a long time, and then some of them, like this, absolutely come out of the blue. And the hacker in me just screamed like, yeah, but I I had been burnt out enough to know that if I wasn't really sure what I was building and why I was building it, I was in for a lot of danger. So I thought about it. And so I could work at Lyft, which is a major rideshare service in North America. We launched in 2012. I had been at the company for about a year at the time. And even though we provide rideshare, the mission of the company is to provide the world's best transportation. And I had gone to Los Angeles earlier in 2018, and I saw kind of the early version of these scooters. And they actually seemed to have a lot of potential. And I really started to see the vision of how I could actually use my mobile engineering technology and abilities to build something that could really transform the way people get around cities. So I saw this full vision, and I got pretty excited. So I asked him to tell me a little more. And he gave me the full proposal, which is we want to build a complete scooter sharing experience just like any of the others in the market. We don't have anything yet. We have no client code, we have no server code, we certainly have no firmware, we definitely don't have any scooters yet, and we have no idea how we're going to operationally do any of this. And we have 2 months to do it before our first deadline. So there was also some huge constraints to this as well, because we're a rideshare company, and we were certainly not going to risk anything in that core product to build scooter sharing. And also, all the stuff around us that we had already built had never considered, oh, could we make that for a scooter? Everything was about rideshare, everything was about cars. So, I thought this could be fun, or it could be a disaster. I don't speak Russian, so I asked my coworkers to help translate. I hope they didn't. Cool. But there's this hacker in me that just said, do it. You have to. This is going to be so fun. And so I just kind of went for it. Yes, he got it right. But I knew that if I was going to do this, I needed something to help guide me. I needed something to make every single moment of this whole process be maximally effective. Kind of going back to the original principle I said, I was only going to get through this. I was only going to have enough time to go home and hit the slopes or go out if I really focus on doing what matters at every single moment. So the very first thing I do whenever I have this tough situation is I pause and I step back, because I find that acting first, which is my normal inclination, usually leads me to do the absolute wrong thing and waste my time. So if I step back, I ask myself one simple question. What was success going to look like here? And honestly, I knew that launching was the ultimate success, but there was a lot more to it. So I thought, what is not success? And that really gets to something bigger. Because if we were to move too slowly, we were not going to reach that deadline, and we were not going to be able to ship anything at all, because the deadline was very hard. But I also knew that if we moved too fast, we were going to build something that didn't really function the way we wanted to. It would have bugs. It would have a bad user experience. I also knew that if we were too disruptive while we were building it throughout that process, we would interrupt our coworkers' code, we would interrupt our coworkers' business processes, and not only would we make them very, very unhappy, but it could potentially just cancel the entire project. But there's one more that I'm really keen on, that I've seen too much while I've been a developer, and that is if you build something that's not useful. So if you build something that your users don't ultimately want. So when I think about it, typical software engineering, we're balancing two things: speed and reliability. How fast can we code it? How reliably does it work? But I found that there's one extra dimension that's so crucial here, and that's usefulness. Is what we're going to be building useful and engaging and solves the problems we want it to? So what is useful? I think that we oftentimes get lost as engineers thinking that useful is somebody else's problem. We often think that that's a PM's job, that's a designer's job. But I think that as a product engineer, we fundamentally are building apps as a human process and intending to solve problems that users and humans are going to use. And those people problems are solved by our technical expertise, but we are not solving technical problems, which means that we're dealing with ambiguity, we're dealing with uncertainty, and we're dealing with subjectivity all the time, which is really different when you think about it. And that's what I really think is fundamental here. This is product engineering, when we build and ship those meaningful products to real-life humans. And so that's what I think. To sum it up, product engineering is when we balance all of those things. That is what success looks like to me. And then I found, if I really thought about it, there were 3 big principles that were going to help me through building this product. And I found that these were really useful when I was working really fast-paced, but I actually think these are really useful anytime you want to be an owner of the product development process. And that is, 1, stay simple and stay lean. 2, reimagine over reinvention. And 3, listen, learn, and launch what matters. So I'm going to break down each of those topics. I'm going to go into what we embraced as part of those, and it's going to go through the story of how we ultimately built out Lyft scooters and launched them. Excited? Yes. So first off, stay simple and stay lean. Effectively build as little as possible, which is my life goal. So, right away, as we were getting going, we kind of had this basic elephant in the room, which is we can't risk interrupting our coworkers. And if we were going to get this project off the ground at all, we needed some form of foundation that we could build on safely. And so, typically speaking, when you're building a product, you're going to safeguard it behind a feature flag. Android, iOS, we're all the same here. We pretty much just have like, hey, if this feature is enabled, go do the thing, which is great. I mean, feature flags are the foundation of mobile engineering. You get analytics, you get so many things for free. But I think one of the problems when you're building something really big is that there's a lot of things that your feature is going to touch that are not just part of that single feature check. And what I mean by that is we have all these features in our app, and we have all of these frameworks that reference them. And part of it is scooters, our request flow needs to know about our scooters because we need to navigate to it. But our background services also we have polling components. We want to store things in our local data store. We have client verification, and other features might even reference it. And this is a problem because if we're going to be building fast, we're going to be doing unsafe things in there. It's going to be in progress, and we can't just have everything in our code base point to it. Luckily, at the time, we had already broke everything out into separate Gradle modules. We had modularized our code base, and so we knew we could leverage this. So instead, we decided we would abstract away the interface for the scooters. And so anytime it interacted with anything in the rest of our code base, we provided an interface for that. And then we actually just had the full implementation, everything, in a separate Gradle module in the same package structure. We used dependency injection to then refer to that scooters implementation. So, this is cool, but what does that really buy you? And not only does this mean that we really reduced the surface area of where this could show up because you had to make an interface file every time you wanted another part of the app to reference it, but it also meant that that separate Gradle module, we really knew we could put it somewhere else. And so we had a no-op module we built that if we loaded that in, we knew nothing was going to happen. It was completely safe. And then we used flavor modules to simply load up for production builds that it was always going to be that no-op module. And then if we had our development builds and our beta builds internally, we would then load up the full scooters project. And so what that looked like is the prod flavor module, we saw that we had no scooters. But then for all of the other ones, we would actually load in the full thing, and all the rest of the app wouldn't know the difference. So then going back to that original code, we would simply know that if there is no feature here, we're returning null. So we can just look at the code and know, hey, this is safe. Which is really exciting, because that really gave us that single section of the app to build from really confidently, which addresses that reliability thing. But now that we've built this really safe foundation, we still have a huge set of features that we want to build. And we need to go through that and effectively figure out the least we need to build. And this is where I go back to that original chart. We've already talked about the reliability part, but we still have to balance between speed and usefulness. And so how do we quantify usefulness? How are we going to make an informed trade-off between speed and usefulness? I've had a lot of thoughts about this over the years. I've worked on many different projects. And what I found one reliable thing to start with is, what is your product North Star? What is your team's vision? What are you going for here? For us, it was something simple. It was like empower users with a convenient, easy to get, an affordable way to get around the city. And this talks about something in user terms. This says, what is the human problem we're trying to solve? And how is what we're going to build going to help with that problem? And it's really, really high level. It doesn't really get into any specifics, but I have found so often when I have a disagreement at work with my coworkers when building something, we can refer back to this to find common ground and to resolve things really effectively. So once we have that, we were able to then define a golden path. And now these are called many different things. I call it a golden path because we're a very step-by-step based company. But in effect, this is the general central user experience that solves that core user problem you defined under really optimal conditions. So you just kind of go squinty-eyed, you kind of look at it from the abstract and you go, hey, is this going to do what we set out to do as our team's vision? For us, we laid it out pretty simply. First thing you do is you got to this scooter's experience. You selected a scooter. We showed you the details about it. You reserved it. You walked up to it. You then unlocked it, and you started riding. Very simple set of experiences. Obviously, it gets more complicated than this, but when we're talking about the golden path, we're keeping it very simple. And then after that, after you've ridden for a while and you've gotten to your destination, you're going to end your ride. We're going to take a photo, which is a requirement, so therefore part of that golden path. And then you would get to your end ride screen, you would rate your ride, and then you would be off on your way. So this was useful for a couple reasons. First off, it defined what we could talk about, does this really solve our core user problem? But then we could also really look at it and say, what's not involved here? What is not so essential to get us towards our goal? And that really helped us. Because I really think that when you're building a new feature as part of an existing product, it's very tempting to want to include everything into there. For us, we had a lot of other ideas. Hey, could you share your arrival time with your friends? Could you set a destination and get a route there? Could you have coupons or promotions? All this stuff we had in our ride-sharing experience, but we didn't know if we needed it in our scooters. But now we have this North Star vision. Now we have this golden path. So we can really quantify and say, what usefulness are we bringing for each of these features? And how technically difficult is it to build? And ultimately, we found out that most of these things we didn't feel like were needed for our first version, which is fantastic because when you actually decide not to build something, you have saved all the time as if you had built it. I just want to let that sink in. Okay, so now that we've really limited down what we actually needed to build, we needed to design a really simple and robust architecture to be able to represent it. And so part of that is we wanted to balance two things. We needed something that would be really straightforward and really easy to reason about, but we also knew that as we were going to be building this, product requirements were going to shift and change. Nothing is ever set in stone when you're moving this fast. So I have an old colleague, or a wise colleague, that once said, the bigger the feature, the more likely it'll take shape in unexpected ways. And this is a photo of a desire path. And a desire path is one of my favorite human psychology concepts, which says that even if I build a path into the ground that says, walk that way, but the destination you want is over there, human nature is just to simply cut through the grass, no matter how much you want to. And I think that goes exactly to demonstrate what a good architecture seeks to avoid. So here's an example of this. We go back to that golden path, and we say, what server-client architecture is going to best represent that? And we have these three states. We have your reserved state, we have your unlocked state, and you have this in-progress state. And similarly, at the end, we have these three states, where you're taking a photo, we're showing you these ride details, and you have this rate and pay screen. So one way we could have done it was to simply say we have one time you're in ride, and we have 3 states for that. And then we have a separate thing, okay, now you're post-ride, and we have 3 states for that. Now, this would have worked just fine. There wouldn't have been, this would have modeled our problem exactly. But I think there's a lot else here. There's a lot of hidden edge cases we may not have considered. Every time we transition from one step to another, we might encounter an error. We may not be adding that many steps, but adding any new step and transitioning to another one is something we're going to have to consider. Could the client support it? Would that be an unexpected experience? And then, are we optimizing for a path our product is not actually going to take? Are we building the biggest sidewalk possible to the end destination that nobody is actually walking to? And so we wanted something that would be really easy to reason about, but also could go through any of these sequence of states. So instead, we stepped back and we said, hey, how could we do this even cleaner? And we just thought, hey, one enum would be way more optimal, way less to reason about. And, I think one of these steps was fairly straightforward. You're in a reserve state. But instead, what we noticed is that so much of the other mocks, the other screens we were building, could actually be represented by a single service state. And that all the rest of the things in there were regarded to either a user interaction or some other part of the data model that really wasn't consequential here. And then finally, we could just lump in all of the dropped off stuff into one state. And by dropping this to 3 states, we really, really clearly knew if the server were to send one state, exactly how it would behave. And then we sent up the simplest polling loop possible to say, what state should I be in? And it would return us a state, and then we would know what screens to show on the UI. This was exactly the same across iOS and Android. It was developed in tandem with the iOS engineer, me, the server engineers, the firmware engineers, the hardware engineers, the designers, and the product managers. We all got them in a room together. We walked them through this architecture. We got their feedback. We iterated. And why does that matter? Well, for example, there's a lot of things about that screen where there are limitations. There are things where we made it so simple, some things are possible and some things are not. But when every single stakeholder was involved in that decision, they knew exactly what trade-offs we were making and were able to then make their own trade-offs within that. And it also made sure that by the end of it, everyone just felt super good about it. Okay, so we've got this simple architecture, we've got this simple foundation, and we've really reduced the amount of features we're going to ship. But now we actually have to go build it. And I go back to that hacker part, and I think about how can I use every single bit of the code around me as if it was like Lego blocks. It was reusable. Because we had a lot of really strong opinions when we first started to build this. Some people wanted this to be an entirely separate app. And some people said, oh my God, we're going to have 100 million users at launch day. Are we ready? I think it's really natural. When you have really tight timelines, you really want to start from scratch and stay really, really small and lean. And when you're expecting this huge amount of stuff at launch, you really want to leverage all of the existing architecture to handle that load. But you know what? I found time after time again, there is a simple, optimal path, which is you focus on creatively reusing the stuff around you that is intended to be reused, and then reduce dependencies on other parts of your code and infrastructure that need to change for you. So I kind of think about it as going back to that very hacker RJ, where what could I look around and kind of use as a Lego block or a connects piece to build what I need to do, even if it may not have originally been intended for it, but I know once it's in that Lego block form, I can actually use it. So here's, as a foundational thing, I think we oftentimes forget how much of our mobile code base is intended to be reused. Everything from your build system, from your network stack, your authentication layer, this is all intended for other developers on your team to use. The entire release process itself, the testing infrastructure we had developed. And when we actually step back and pause, we find that actually any development at all is really not possible without all of these foundational things. And not only is it important to take it, to not take it for granted and to appreciate it, But it's also important to remember that this is one of your greatest weapons when you are building things really fast, to be really aware of what is already made for you to reuse. But obviously, there's catches here. And I found it could be summed up really simply. When you have to ask another team or ask another person or a stakeholder to change their system for you, you're depending on another human to do something for you. That can be one of the biggest roadblocks. But you have options. And the biggest thing I want to remind people here is that as a mobile engineer, it's your job to explore the different options and communicate them with your team. And let me show you an example. So we frequently asked if we could kind of push the state of the scooter to the client. We have an RX Java API, and it supports an observable for our API, but in the background it's just polling. And it has a simple header in the response to tell you what the polling rate should be. And it was pretty long because this was going on all the time. We asked the team, hey, could you build push for us? And they said, it's coming, do you want to wait? And that's exactly what I was worried about. So no, I don't want to wait. But let me see what I can do. So we diagnosed the issue with our team, including the product managers and the engineers. And when you have this long polling rate to tell you what is the status of the ride, if there was an event from the hardware right after one of those polls, you would be waiting a very long time in the app before you saw that update. And it was very weird, and it was very strange, and you might think that something was wrong, and you might cancel your ride, which goes exactly back to what I thought about usefulness. If this is not as useful, then we have a problem. So we explored the trade-offs with our team, and I think one of the product managers suggested a couple different options, and so we explored it. And one of the things we noticed is that if we did know some very specific times on the phone where there might be a high likelihood that something is going to change, we can override our own local polling rate and increase that so that if there was an event going on the hardware, the polling would pick it up much quicker. And once we described that to the PMs and we worked through it, we were able to convert that into some very simple code. And for here, this is an RX Java system where we emit a unit event to re-trigger the polling anytime we notice anything about our hardware has changed or user interaction has changed. And it may seem really simple, and it wasn't that much code, and it was easy to test. But when we went back to our PM and we described the situation, they were all very, very happy with it. So we didn't depend on another team, but we were able to get something close to what we had wanted from them. But sometimes this doesn't work out so well. We had a question come up early on, which is, can we put a driver's license scanner in the app? And I'm thinking, oh my God, I need to include camera APIs, and I need to include all of this native code. This is going to be scary. I don't really want to. But then they just said, hey, I think the driver app, the driver team for the ride-sharing company, has already thought of this. Can you go take a look and see? And I, very skeptically went and found that they had built a view to do this, which is exciting, but it, wasn't exactly what we needed. So this is where I take a lesson of composition over inheritance. So when you really like something and you want to reuse it and you want to turn it into a Lego block, you have options. And so what we did was we took their code verbatim. We didn't touch it at all. And we wrapped it, and we kind of took a look at the mocks we were supposed to build, and we wrapped it inside our own code. We made our own overlay for it. We wrapped it inside of its own view controller. And using our own custom framework, we were able to kind of make a pluggable piece out of it that we could use for our own purposes that left their code completely untouched. We didn't rely on them to change anything, but we got something for free. And then when I came back to them, they were all super happy. And when I make my PMs happy, life is good. But I found one thing that I spend the most amount of time on. I don't think this changes iOS to Android or any mobile platform at all. But UI time spent managing pixels, is absolutely killer when it comes to timelines. And if there's any way for me to find a way to reuse this time, I was going to go at it full steam. I don't know how many people really enjoy UI work or find it a great use of their time. Okay, no, it's fine. Personally, as much as my partner is a designer and I love design, but it really, really is tough to get that looking perfect. However, at this time, we had just launched our Lyft product language. I don't know if anyone has a design system they get to work with at work. They're awesome. I love them. So for us, we had this big set of UI elements kind of being built that had all sorts of things built into them for free. Usability, consistency, accessibility. We could just kind of look at the mocks if they were kind of in this framework. And we knew all the stuff about it, the font size, the colors and stuff. And it was really robust, and it had a lot of elements in it. And there's a lot of stuff that I, as a mobile engineer, really spend a long time doing that this gave me for free, like loading states, like a really nice loading states, but also like disabling it and the animations in between. Things like internationalization and accessibility, the ability to like shrink the text in a button if you're in a language where the text is much longer. Not only that, but it would be consistent across the rest of our app. We could just use it and knew that our users would enter the scooter experience without being like, oh, whoa, stuff changed. And we also knew we were working with good APIs already out there. And I'm super thrilled because our designers care a lot about Android. So much so that we won this Material Design Award back then, and I like geeked out and holded it. It's actually really heavy. It's really cool. I'm such a big fan of this. But I also really loved that secretly, even though our designer would only give me iOS mocks, I didn't really care because I knew how they really literally translated to Android. And this was not only really powerful for me, but I also knew that the designer was never going to give me Android mocks. But you know, I think that the real key here was the common language we had developed. When I saw a mock from him, when we were able to have a communication with the same language, stuff went way faster. And when I got involved early on, when we talked about these mocks in an early stage, it avoided that dreadful scenario where your designer has spent 2 weeks with the most excellently laid out mocks, and you get them and you go, I have no idea how to do this, which is a waste of their time and ultimately a waste of yours. So this is the conversations we'd have. Early on, I would walk by the designer's desk, I would see the mocks that they had, and I was like, hey, that button, is it part of the Lyft product language? And the designer was like, no, I'm just kind of doodling and doing my own thing. You know, it's always important to support people and to give trade-offs as opposed to saying no. And I said, hey, look, I love it. It's a really cool looking button. I just want to give you just a heads up that this would probably take me a week or so to build. I mean, there's a lot to this. But you know, if we had used the Lyft product language version, it's probably going to take me about 20 minutes. So the designer's like, oh, cool, yeah, that's a good use of my time too. Thanks for asking. And once again, this goes back to what I'm saying about waste less time, because I didn't do anything code-wise, but I had saved so much time of coding. So I also have to say thanks for the Lyft design team for making this. I have to show a lot of appreciation because it's that foundational element that lets me move fast. But there are a lot of times you can't reuse anything. I think custom UI components really exemplify this. They're not part of your product language. There's something special and new, and it's actually really cool to embrace it. For us, this was our map bubbles. So we abstracted away our map interface a long time ago. It's really great, but we really hadn't used a lot of clustering before. We had been using our map to show you where your driver is and where you are, but you don't normally have 100 drivers. So we had no clustering natively available in our code base. And I knew we needed it because we were going to have a lot of scooters on the streets. And if we had no way to cluster them, you would have no way to actually find which one worked for you, and you wouldn't be able to actually use it. So even though we didn't have access to clustering, we needed some way to figure out how to make it. And when I'm in a crunch, and I actually have to do my own custom code, I have a very simple optimization. I want something that's readable, predictable, and just kind of works well enough, given the data that I expect to be going through it, versus something that's complex, but I know is going to work in every single situation. And this runs very counter to my software engineering background. I have a master's in computer science. I can tell you the difference between asymptotic runtimes of probabilistic algorithms. And so I wrote something in n squared time that can definitely be done in n log n, which feels so wrong, yet I knew was so right. Because this was easy to read and easy to reason about. And I knew it would work in every single case I was going to put it in. It also took me virtually no time at all to code. And I also knew that it was just one simple to-do to yank this out and put in something better once I actually get to that. Which brings me to the final segment here, which is how we listen and learn and we launch what matters. Because I find so often that as your product is approaching its release date, as you enter the real world, you run into a lot of challenges that as an engineer, you might not have considered. And so there's two kind of parallel questions we had nagging on us the whole time. The first one is, are we actually sure we're building the right thing here? We kind of had doubts as to the product we're doing. And secondly, are we sure that actually if we launch this on launch day, this isn't going to go up in flames? A very reasonable question. So I'm going to talk about the first one. What matters to our users? You know, we had so many questions because this had never gone live before. We had no way of knowing what our current customers would think about a Lyft scooter. You know, would they use that new reserve feature we kind of built into our fundamental experience? Would they understand how to lock and unlock them directly through our app? But I think there was something much bigger, which is just like, did they want to use our app to get a scooter? Is that something that would even resonate with them? Or are they going to be like, oh, this is only for rides. I'm going to put this down and get another app to get another scooter. So if you already have a feature out in the world and you're iterating on it, you have a lot of ways to handle this. You know, I think A/B testing is huge. You know, you put something behind a feature flag and you slowly roll it out to a percentage of your users. You get information like, what's the user behavior change when you introduce this? What are their preferences? And as you slowly roll out, you can catch any bugs and roll it back. You know, this was completely new. We had none of this. So we had to find some other way to do this process. And for us, how to learn when you're not live is really simple. Foundational research and usability testing guided by our research team. And we had actually gone through a ton of different user studies where us, the engineers, sat down next to our users as they were going through the app, the early prototypes, asking them how it worked, and we were able to understand what parts of the experience they got caught up in and what parts they weren't. And we also did a lot of foundational research where we would take groups of users and just bring them in and show them a scooter, like shown here. And we just ride around with them for a while and kind of understand what they would like out of this and what they wouldn't. And I really do think that this was so key as part of it. And that relationship that I built with the researchers was so important so that I knew internally that the small decisions I was making every day were going towards the right cause. But secondly, are we ready for launch day? And this, I think, is such an existential question that you're never really ready for, but you have to do everything you can when you prepare for it. So this whole process, as we were building out this app, we were also building out the server code, the firmware code, and the hardware itself. And we couldn't wait until one of those layers was done to build the next one. We needed to do the best we can. So we mocked every single layer until the next layer was ready to go. So what I mean by that is we had a lot of things in our code base where we would start with one level of return blank, and that as we develop more and more, we would build out the service to represent it. We'd push that down farther and farther and farther in our client code, modeling what we knew the server was going to be replying until we're just basically modeling API responses. And we got so far as to simply write mock servers that when we gave an API reply, would reply a second later with what we expected. And this let us build out our client experiences with the expectation that once we plugged in that server at the very end, we would get the identical experience. But don't forget to actually remove those code because you'll get super excited when it works, only to realize that you hadn't actually talked to the server And so you weren't actually testing anything. But the server part was really interesting too, because once we even got the server hooked up, it didn't mean anything if the server itself wasn't getting any information. So this was where we actually just heavily leveraged scripting. I did Python for about 10 years before I learned Android, and I thought that I would be able to go back in and write some top-notch Python for scripting. I did not. It was very hard. But that was my major contribution, was adding a janky test-writable script where we were able to emulate what the hardware would be sending to the server. And then we were able to test that the server would then send the right sequence of states to the client that we would then render in the right way. And then finally, we stitched it all together. When you get to this spot, it's really important to know that plugging anything in for the first time is probably not going to work. Like almost certainly, definitely not going to work. We found a lot of tweaks to the app were necessary. We found that on iOS, one of the developers tried to reserve a scooter and noticed that it wasn't working. And it turns out that they had been in a ride for the last 10 days and had racked up a $1,000 charge because they didn't see it because one field that the server was replying was null. And because that field was null, the iOS client was simply throwing out that entire API response because it didn't understand it. And so only once we flipped that, we noticed the charge. And then we also had a problem on our hands because if we actually ended that ride, the server code was hooked up to actually charge him that much. And the finance team did not like the idea of expensing this $1,000 ride. So we went into the database and rewrote the times and then finished it. But we also knew that all these integration things, that they required a lot of concerted effort between all the stack layers to come together and do it. When we finally hooked it up, we would have problems with how each layer treated nullability. We had a lot of problems with how each section of the app or the hardware would treat different states. And we had one instance where we actually had to log in directly to the AWS instance and tinker with the Python code to see what was going on. And I called it. It was the enum mapping. So I was super excited. But once we got it working, it's like really, really exciting when the whole thing comes together. And it's like you have to savor that moment because you only get one of those per project. But we still had this fundamental question. Even though we got each part of it end-to-end working, were we really ready for launch day? And I think that this is where you have to embrace building for flexibility. Because what you put out there in the wild as a mobile engineer is inflexible. You can't change your app once it's in the Play Store, once it's in the App Store. Where can you add all that flexibility then? Where can you add space for all those unknowns? The server. We had to find ways to push all the complexity we could, all the dynamism we could to the server. This meant feature flagging individual aspects of our code. So we could turn on and off different parts of it if there was an issue, if we needed to roll out a different market, if there was different constraints that came out. Secondly, we had a lot of configuration flags we sent down to the client to control things like what's the polling rate? How long should we wait for certain operations? How many scooters should be shown as part of a cluster? Finally, this one was key. We had the ability to override any resource that the string or that the app rendered on the screen from the server. And this was amazing. We simply have a way on the client or a web interface to type in the exact name of what we're referencing it on the client and give it its own override. And then on the Android client, we grab this list and we wrap our resources object so that once we actually load up that resource that the view is looking for and we have an override from the server, we'll grab that one instead. And this saved me when I actually got the hours of operation wrong. We were to override that, and nobody noticed. So yeah, this is something that we had built in for a long time, and we intended to be using in a lot of different other parts of our code. But it was part of what we were leveraging to reuse it in a different sense, to actually change different parts of our UI that weren't intended, well, yeah. So then finally, launch day comes. And we actually were out on the field as engineers debugging things in real time. These are actual users of the app. They were photographers, so they really liked taking photos of this experience, which was great. But they really were having issues with the app. And so I just actually pulled out my laptop in real time. After talking to them, I jumped on our debugging console and found out that we had an issue in our experimentation and that some users were actually not seeing our scooters that they were supposed to. And this was super exciting to be able to be out in the field and to assess these issues. Because when you launch something, you can kind of just press a button on your screen at home or at work, and users start getting access to it, but you have no real connection with them. So when you're actually out there in the world witnessing how people use it, you really understand the context to which they do. And this is where we did. We asked questions, we got feedback. And over time, as we launched new markets, we got tons and tons more feedback. And then we went back to that original North Star vision, and we refined it. We kind of knew what mattered more to our users over time. We understood the bigger challenges we face, the bigger ways to add in flexibility. And this helped us figure out how we were going to scale up this product more and more and more. So I want to give you these key takeaways. Is that my motto in life is waste less precious time and build more meaningful stuff. And I think that as a product engineer, I have found 3 simple ways that really drive that home. And that is to maximize the effort I spend every day and to always find ways to chop out the empty stuff, to chop out the stuff that I knew I could do a better way, to take full ownership over what I'm actually building. So to get involved in the product process, to ask the questions of what matters to my users, to embrace the ambiguity of usefulness. And then finally, to laser focus on shipping something meaningful. And that's figuring out the release process, figuring out how you assess meaningfulness, talking to research, talking to your users. And then I found these 3 principles we use to hammer that home. Stay simple, stay lean, reimagine over reinventing, and listen, learn, and launch what matters. So thank you very much. If you're in the US, try Lyft Scooter. My coworker, Dennis, was at Mobius St. Petersburg earlier this year and did a great talk about how our mobile team has scaled. And yeah, we are hiring all sorts of mobile engineers around the world. Thank you very much. I can take some questions.
Please raise your hand. Yeah.
Hi, my name is Alexei. You talked a lot about usefulness, but you also mentioned that even before lunch, you had already Lime Bird there. So, like, did you see your product like really different, or you just wanted kind of to stop them eating share of the transportation, like because you're a transport company? Or like,
yeah, I mean, that's a very fair question. I mean, I think that there is some ultimate sense of usefulness of if someone else is already doing it, do you need to do it as well? But I strongly feel like Lyft, having already have a rideshare business, had the ability to, I kind of think bigger picture about it. So if we had scooters, we would have ways to kind of leverage everything else around us to build something that would last. And I think there was also a big question at the time of were those companies sustainable in what they were doing? Was there gaps in their user experience that we could do better? And one of the biggest things we really firmly felt from the very beginning we were going to do better than them was we didn't rely on other third parties to maintain these scooters. We actually hire our own team to go out and perform maintenance every night on them. And that we strongly felt like was something that our users would like better. Yeah. Yep.
Thank you. And one question, did you meet the deadline?
I suppose I didn't say that. Well, fun fact, the deadline fell through.
2 months, you said about 2
yeah.
months.
So the original deadline of 2 months fell through, but there was another deadline at 2 months and 2 weeks for another city. And so when the original deadline went through, we spent 2 weeks packing everything up and going to Denver, where we launched there on time. So we made a deadline, but we were completely operating under the presumption that we had that 2 months, and we did make that original deadline and then transitioned.
Hi, RJ. Thanks for the talk. So the question is, so you have 3 product engineering principles and you have 3 engineering principles, right? So are they somehow connected? Did you think about this? Are they basically independent and you don't need to connect them, or there is any?
So I think that, yeah, I realized that I kind of worded that badly. So I think that there's 3 product engineering guidelines of how I felt were really useful in kind of connecting me to my mission, which is about not wasting your time and taking product ownership. But I think those are very abstract, and they don't kind of get at exactly what I should be doing at any given time. So I think the engineering principles talk much more, how do I translate my day-to-day work towards those bigger guidelines?
So basically, engineering principles is like day-to-day representation of overall engineering guidelines. Let's say that.
Definitely.
So they are connected in this way. It's like one-to-one, or is it just general, all of them?
So it's definitely not one-to-one, which is where I think the reality of it comes in, where I think that staying simple and lean is something that goes to taking product ownership, but also very strongly to building, spending meaning, or making meaningful use of your time, reducing the amount of empty time. You kind of do both when you kind of trim the features that you're building. So I think that there's 3 and 3, but they're not a linear mapping between them.
Okay, thank you.
Hello, thank you for all of this. It was really interesting and fun. So you were talking about design system. It's really beautiful. And do you have somehow server-driven UI or something? I mean, how do you store all of these strings on your buttons and these beautiful views? I mean, all of this text. Do you get this from the backend, or how?
I'm not.
Was I clear? Sorry.
Sorry, I'm not quite sure I understand. Are you asking like where we get the strings from, or?
Yeah. How do you get it?
So we have all the strings kind of typical Android development. We'll put them in a strings.xml file local to each module we're building the feature in, and so that lets us kind of scope. It lets us reuse the element, but kind of put the string in a safe and translatable way that kind of go into each language, and then we only send down a server override if there's something wrong with the client built version of that string. So we don't. We try not to have everything dictated by the server. There are obviously some exceptions to that.
Okay, thanks so much.
Yeah.
More questions? All right, then. Oh, one more.
Thank you for the presentation. One small random question. You were saying that you poll write status every 30 seconds. Why not just use push notifications to initiate the polling?
Because our client infrastructure team had not built it yet. I think that a lot of times there's an obvious solution, and a lot of times your coworkers will say, "Why didn't you use the obvious solution?" And I think it's interesting because it's our job to not be defensive about it, but just simply say, "I'm sorry, the other team is not ready yet." We can ask them, but then we're kind of risking them not shipping on the date they said, and then we don't ship at all. But yeah, we still don't have it, actually. It's very hard to do push networking at our scale, I guess.
Sorry, once again, just iterating on a strings question. Do you like send a whole bunch of strings in like initially when you receive a config, or you just receive like per screen, like the overrides?
Yeah, so that's a great question. We really try and keep these overrides to a minimum. They're really intended for if something went very wrong. And so that they're all loaded up at our initial configuration time. I guess the key is that that's actually done passively on app start. So we don't block on that call. And it's the next time you open up the app, you would get those new configurations. So for anything that we need more real-time stuff, there'll be a custom call to do that in real time. But otherwise, it's app start.
Right, thanks.
Yeah.
Thank you.
Well, as for the deadlines is concerned, what is the deadline for launching in Russia?
Yeah, I think that we haven't seen international scale at my company for a lot of reasons. I'm really excited about it, but it's one of those things where you really just have to, there's so many challenges that come from scaling internationally. You have to kind of pick and choose where your efforts are. So I think that we'll definitely do it when we're ready to, but we've got a lot to go.
I know a lot of good guys would join you.
Oh yeah,
for sure.
Oh yeah, I'm excited too.
Yeah. Stay in touch then.
Oh
Thanks.
absolutely, yeah.